Hi, this video is dedicated to how suspension is arranged in a car. If you are designing a car or you are doing your project in real life, you have an ordinary car or buggy, this video will be useful to you. Let us start by understanding how our arms move, because any suspension is made of arms. You can see how the arm is fixed on the right side. The lines you see show how the angle of the arm affects the position of its left side. Therefore, you should understand that any movement of the lever is a movement in space. If the arm is fixed on one side, the other side will always draw a circle. There are two arms in front of you. One of them is almost twice as long. They rotate to rise to the same height, but the short arm has to rotate 45 degrees to do this, but it has twice as much as the long one. And so, if you have graduated from high school, you are familiar with physics and geometry. This will be useful for us in order to understand how stiff the spring should be and at what angle to position it. If the force vector directed upward is 1 Newton, so we have to apply a force in the opposite direction equal to 1 Newton so that the arm retains its position. Thus, the spring on the left is connected 10 centimeters to the right of the end of the arm, and it should be 10% tougher. The spring on the right is connected in the middle. This means that it must be twice as strong. But since the spring is at an angle of 45 degrees, its force in the lower position of the arm is less than you might think. You see the formula by which we can understand that if the stiffness of the spring is equal to 2 newtons, then at the point we will get less than 1.5 newtons, which means it won't be enough. But pay attention that when the arm goes up, the angle decreases, which means that the force that the spring creates will increase. Okay, I've made several types of front double arm suspension. Let us look at them first. And so, let us start from the beginning. This is the simplest method. All suspension arms are the same length. Here we see that the upper lever is at an angle and the lower one has become longer, which is why our wheel will have a positive slope in the upper position. You should watch other videos to understand what it is and what it is for, but I must say right away that this scheme cannot be used. You may also have noticed that the wheel turns slightly. This happens because the tie rod from the previous example is not suitable for this example. To prevent this from happening, the tie rod must be longer and have a different position. In this example, all the suspension arms are of the same length again, but this time the upper and lower ones are positioned differently. This time, the wheel in the upper position will have a negative slope and it does not turn when lifting and lowering. In this example, we are faced with such a thing as a caster. The caster allows our wheel to align. The larger the caster angle and the higher the speed, the more the wheel will tend to its original position. Now we will leave the caster angle and tilt our upper arm slightly to get a negative tilt in the upper position. And yes, this can be called a formula for success. This type of suspension is called a McPherson. It is often used only in the front. The main difference is that there is no upper suspension arm. But you probably noticed that the hub is turning again. This happens because it is extremely difficult to calculate the length and position of the steering rod. We can also set the tilt of our hub. To do this, you will have to move the upper mounting point of our spring. As you can see, the length and position of the tie rod is not suitable for this scheme and the hub turns strongly when lifting. That was the end of the lesson. Thank you all for your attention. In the next video, I'll talk about Ackerman's corner.